table below to answer the following questions. And let's assume all populations are in fact normally distributed with common variance. So basically this assumption assumes all the assumptions related to 1 million ANOVA test are satisfied. So you don't need to worry about whether you should use ANOVA or not. Right? So now based on the table below, what is the value of K? And then what is the test statistical value and the p-value for testing whether the K groups are different or not. So when you have an ANOVA table like that, right? So you have to think about all the relationships among those numbers in an ANOVA table. Right? So let's start with the degree of freedom here. We know the degree of freedom for total equal to what?
Why or something?
N minus 1, right? N is the total sample size. Right? So in this case, equal to 54. So therefore, total sample size has to be equal to what? 55, right? So 54, N minus 1 equal to 54. Therefore, N equal to 54.
This is the only question I'm going to get right.
You move this to the right-hand side of the equation, right? N equal to 55. So that's the total sample size you have. Now, if you read this question, right, so you have K different groups, not 5, K different groups, and that you have 5 observations within each group. So therefore, how to calculate total sample size? You use 5 multiplied by K. You have 5 observations per group, right? So therefore, total sample size equal to 5 times K, equal to 55. So this one, then we know K has to be equal to 11, right? So that's the value of K, 11. So we actually compare 11 different groups. Right? Now, once we know the value of K, the degree of freedom for treatment equals to what? K minus 1, right? You see? Oh, this is a mess. That's this thing. So you have to memorize. Yes. Degree of freedom for total, right? Degree of freedom for treatment equals to K minus 1. K is the number of groups.
Just the degrees of freedom?
Yes. Between the three.
So therefore, degree of freedom for treatment equal to K minus 1, 11 minus 1 equal to 10. So basically, here it is, K minus 1. 11 minus 1 equal to 10. Okay? Now, the degree of freedom for error term. So you know 2 of these 3 numbers, right? So therefore, the third one simply equal to 54 minus 10. You have 44 here. Oh, in another word, this one equal to N minus K. You have 55 observations, right? N minus K, 55 observations minus 11 groups, you also get 44, right? So that's how you complete the first column there. Now the second one, so if you look at the data vertically, you only know 1 number. There's no way you can calculate this, right? You need at least 2 numbers to calculate the third one. So therefore, you cannot do anything right now. So if you move on to the next column here, right? So we do have another value here. Now, the mean square error. Remember, mean square error is calculated this way.
Oh well.
So mean square error equal to sum of square value divided by degree of freedom, right?
At least I'll get one problem right.
Equal to whatever the value here, the sum of squares of the error term divided by 44 as the degree of freedom, right? So therefore, the number here, that's the sum of square error term equal to 6 multiplied by 44 equal to 264. Okay. So we have to look at the data now horizontal, right? 44 here, and here, and then this one 264. Okay. Now, if we go back to the sum of square column, we know two of the three numbers. Therefore, we can calculate the third one, right? So 360 minus 264 equal to 96. Am I correct? Yeah, I think so. Oh, 86. 96. Okay. Yeah. Yeah, 96. Now, mean square error. So now we know the number in the first row, right? So therefore, the mean square error for the treatment column equal to 96 divided by 10 equal to 9.6, right?
How did you get 96 again?
Oh, 96 equal to 360. So we look at data vertically. Minus 264 equal to 96. Yeah. Now this number equals to 96 divided by 10. You get the mean square value, right? Now, F statistics equal to the ratio of these two numbers, right? So 9.6 divided by 6 equal to 1.6, right? Now this F-test statistic follows an F distribution. So for p-value, there's no way you can calculate this by hand, right? You use this data command. The degree of freedom for numerator equal to 10. Degree of freedom for denominator equal to 44. The value of the F-test statistic equal to 1.6. So you have to use a data, right? So display F tail and then 44. 10, 44, right? Numerator is 10. 10, 44, and then 1.6, right?
44.
1.6. Okay, so now the p-value equal to 0.138. So that's your final answer. Okay. So that's the p-value. So for the second question, what is the test statistical value? So that's F value, right? It equals to 1.6, and you have to report the degree of freedom, right? You say the F test statistic equal to 1.6 with 10 degree of freedom for the numerator and then 44 degree of freedom for the denominator. Or you can write this like this: F 1044 equal to 1.6. Right? And then the p-value equal to 0.138. Now, in order to get partial point, you can write down p-value equal to, you give the formula here, right? And then give the final p-value here. Now, for your exam, right, because no software is allowed, right, I will either give you data output or I give you p-value directly, right? Then you don't need to worry about calculate p-value yourself, right? So now based on this p-value, what's your conclusion? Are the K groups the same or not? So the null hypothesis will be they are the same, right? There are no differences. Now p-value in this case greater than 0.05, therefore we fail to reject the null hypothesis. So there are no differences across these 11 groups. So that's the answer. Any question? Okay. So once again, the deadline for your 7th homework has been postponed to this Friday.